Hello, my wonderful students and chemistry lovers. Today I'm going to show you how to calculate relative abundance of isotopes. My name is Dr. Rotanna Okwesili, and I'm going to serve as your guide today in this interesting lecture and conversation. Okay? The question says nitrogen has two isotopes, nitrogen 14 and nitrogen 15, with the average atomic mass of 14.007. The question now says, calculate the relative abundance or calculate the percent abundance of each isotope. In order to solve this problem, we create a table that will help us to itemize the different components of the question for clarity's sake so that it is easy for us to walk through. The first column we have isotope, the next we have mass, and of course the percent abundance. The isotope is N14 and of course N15. And the mass number here is 14 and the mass number of the second isotope is 15. Of course here is percentage abundance of the first isotope. We don't know it, that's what we're supposed to find. So we represent the unknown with X. And of course we don't know the second percentage abundance of the second isotope. N14. So in this case, we represent it as Y as well, showing that it is unknown. The next thing we're going to do is say 14 into X. 14 into X is equal to 14X. 15 into Y. 15 into Y is equal to 15Y. Okay? Then, from the information we are given, the average atomic mass we are given is 14.007. We're going to change this information we have generated into a linear equation. It will help us to walk through the question to find our solution. Doing so, the first information is 14x plus the second information 15y is equal to the third information 14.007. Permit me to call this equation 1 just for clarity's sake and to make and simplify our question as we're solving it. Okay? To simplify our solution as we're working through it. So permit me to call this equation 1. Now, we are expected to find the percentage abundance of X and percentage abundance of Y. That information makes us to understand that whatever is percentage abundance of X added to whatever that is percentage abundance of Y should be both equal to 100 since we are talking about 100%. Okay? Now, for the purpose of solving this particular problem, in order to make it less ambiguous, we are going to convert this 100 to the decimal. So we are going to change this 100 to 1. However, at the end of the day, when we finally find the X and the Y, we are going to convert the X and the Y back to percent by multiplying whatever value we have here in the X and Y by 100. We are going to come to that. So permit me to call this equation 2, just for organization and clarity purpose. Now, from this equation 2, if we want to make y the subject formula, we will know that y is equal to 1 minus x. Permit me to call this equation 3 as we proceed. Now, next thing we're going to do is to substitute for y in equation 1. Wherever we see y in equation 1, we substitute it with 1 minus x. So in that case, we say substitute for y in equation 1. Very important. Okay? So equation 1, of course, is 14x, okay, plus 15y, okay, equal to 14.007. So for us to now substitute, we have that 14x plus 15. We change y with 1 minus x. Bracket 1 minus x is equal to 14.007. Very fantastic. We open up the bracket. So 14x plus 15 into 1 is 15, okay, minus 15 into x is 15x is equal to 14.007. Nice. Next thing we are going to do is to collect like terms, okay? And in doing that, 14x minus 15x is equal to 14.007, okay? Plus 15, crossing sign of equality becomes minus 15. When we do that, the difference between 14x and 15x is minus x, equal to the difference between 14.005 and 15 is minus 0.993. Okay, so minus cancel minus, we find that x is equal to 0.993. We hold our hands on this for now. All right, and then we are going to solve to find y, and we are going to use equation 3 to do that. And for us to do that, you substitute for s, okay, using equation 3. Using equation 3, we have, okay, we have y is equal to 1 minus x, okay? So we are going to now substitute for x, substitute for x in the equation, okay? So when we have y is equal to 1 minus x, of course, we know that x is 0.993, so it becomes 1 minus 0.993, okay? Y is equal to, when you do the difference, you are going to find that y is equal to 0.007. That's what you have. 0.007. Okay, like I told you, we have been able to identify what x is and what y is, and they have their decimal, as you can see. Next thing we are going to do is to convert from decimal, okay, to percentage. We do that by multiplying, okay, x and y by 100. Very important. We multiply x and y by what? 100. So if that is the case, we now know that x is equal to 0.993 multiplied by 100 will give us 99.3%. So the value in percentage here is 99.3, of course, percent. To do the same for y, and y is equal to 0.007 multiplied by 100, which is equal to 0.7%. 0.7%, okay? 0.7%, okay? So that is that, 0.7%. 0.7%. You see, if you add 99.3 to 0.7, both of them is going to amount to 100. Okay, when you find or convert x from decimal, of course, to percent and got 99.3, you could easily, instead of going further, you could easily say that y, okay, or percentage y is equal to 100 minus, okay, percentage x, okay? And if you do that, you will see that percentage y is simply 100 minus what you got here, which is 99.3, okay? Which is that your percentage y, okay, is equal to 0.7%. 0.77%. So this is how, okay? So this is how to calculate, of course, the relative abundance of isotopes. I don't know if you enjoyed today's class or today's lecture. Kindly click on the like button or the love button on this my video on this Facebook, okay? And follow the page Chem Class with Dr. Lotan on Facebook. Of course, on YouTube, all my videos will always be uploaded there on Dr. Lota TV. Then you can as well follow my personal page if you want to know about my daily activities, what I do, and of course, my radio interviews. You follow me on Dr. Lota on Facebook. Share, kindly like and share my video. Make some comments, and we're still receiving topic requests from different places. We are going to be treating them one after the other. This is one of the topics that somebody, a student, asked us to treat, and we have been able to treat it. So in subsequent editions, we're going to continue to give you exciting and interesting topics and solutions as you have just seen. Thank you for watching. See you next time.